So, have you had enough of adding and subtracting fractions? Well, good, because we're moving on to the next thing. Now we're multiplying fractions. And good news, this is a walk in the park compared to adding and subtracting, because when you're multiplying, or dividing, which we'll get to in a bit, you don't need a common denominator. All you have to do when you're multiplying fractions is do top times top, bottom times bottom. So when you're given these to multiply, the numerators are 7 and 1. 7 times 1 is 7, and the denominators 10 times 5 is 50. Now, having done this, you should look at the fraction you've created and think, can I reduce this in any way? In this case, the answer is no. 7 and 50 are relatively prime. They have nothing in common. So that's the end of that one. Here is one that is reducible, I'll tell you that right now. And I'm going to do this two different ways. The first time I'm just going to do top times top. 9 times 5 is 45. And downstairs 10 times 6 is 60. Can this be reduced? Yeah, it can. Both of these numbers are divisible by 5. If you're disappointed I picked 5, I know what you mean. We'll get to that in a moment. 45 divided by 5 makes 9. 60 divided by 5 makes 12. Can we reduce this any more? Yeah, we still can. Both of these are multiples of 3. If we do that, 9 divided by 3 is 3. 12 divided by 3 is 4. So it turns out our answer is simply 3/4. What I was getting at with the disappointment remark is that from here, if you've had your morning coffee, you may have noticed that both of these numbers are divisible by 15. And if you see that, terrific. You can divide them both by 15, and you'll get to 3/4 just like that in a single bound. I did it this way to show that it's all right if you don't catch this great big bite here. If you catch any number that divides out of both of these, then good, you're making progress. Just look at it again after you're done and think, can I go any further? Keep going until you get to a number like this where the answer is no. There's nothing I can divide out of 3 and 4 simultaneously. So, two ways that we can get 3/4. There is a third way where you reduce before you do the multiplication. All the way up here, when you have these fractions, you notice we have here, for instance, a 5 in the numerator, a 10 in the denominator. Before you even multiply, it is legal to say I'm going to divide the numerator by 5 and the denominator by 5. And the way that usually looks is you go 5 divided by 5 makes 1, 10 divided by 5 makes 2. There's another one of those that we can do here. Do you see it? We have 9 over 6. You could say 9 divided by 3 makes 3. 6 divided by 3 makes 2. Now, you can see how cluttered this is getting. Even with me trying to color code everything to keep it readable, it becomes a bit of a mess. So write big, try to be neat, and if you think that it's getting so cluttered that you're losing track of what's going on, rewrite it again so that you don't drown yourself in your own mess. But once you've done these reductions, then you multiply and you get 3 times 1 is 3, and downstairs 2 times 2 is 4. So this method, the downside is it's a little bit messier, but the nice thing is it keeps the numbers much smaller. You don't have to worry about reducing things like 45 and 60, which are a little bit harder to deal with. This is certainly the way you want to go if you have very large numbers at the beginning, because if you get a fraction that's like 368 over 512, it can be a real grind trying to reduce that. Almost nobody knows their times tables that high, and so you can save yourself a lot of grief by doing the reduction before you multiply. So either one of these that you like, they both work fine. This first one is slightly preferable when the numbers are a little uglier. But pick one that you like and run with it.